Thanks so much. Thanks for the warm welcome and the touring today. Thanks for having me. And I'm going to switch this deck for a second. Okay, so the title I picked is Verifying Field, which is the title of our book. Architects know what I mean when I say verifying field. It's those three little letters on your drawings. I circled it here. It's a architectural notational convention that signifies that the material in the drawings is limited, that requires input from a contractor, a surveyor, fabricator. Some people say it's CYA, but it's really actually opening up a conversation. So when we were thinking about how to give a title to our book and what would sort of encapsulate a kind of working ethos, we thought Verifying Field is really about a series of feedback loops between the design process and the construction process, between thinkers and makers. And sometimes that rift between the people designing and the people building produces not the best outcomes. And I've been thinking about that, and that sort of led to the next book, which Brad referred to as Design for Construction. But today I want to talk about verifying field and these sort of dialogues that we open up with our drawings. I think Lutyens said an architectural drawing is a letter to a builder. And I think that's a beautiful way to think about it, right? It's not a picture. It's not a painting. It actually is information. It's actually contractual. But if it's a letter to a builder, what kind of letter is it? Is it an admiration letter? Is it a love letter? What are you trying to get done in the world? We say architects work on the world at a distance, and this is a building I worked on when I was a young architect. But I was working on this part, right? The kind of clicking and snapping and locking and the mouse work that produced this condition. But the gap between the world of AutoCAD and viewports and things and the world of the kind of muddy, rusty, gritty, wet, rainy, slippery world, that's a huge gulf. And how do we sort of think about bridging that gulf? In a way, that's what this lecture is about. I've been collecting photographs of builders. These were actually taken by my great uncle, Cas Oorthuis. He was photographing the construction boom in Holland after the war as they were trying to rebuild. And some of these pictures, they could have been taken yesterday. And some things about construction don't change at all. Some things change a lot. And so I've been thinking about, what is it about these images that seem timeless? And what is it that seems like that hard hat looks a bit old-fashioned? The instrument probably works on the same principle, right? The cigar. I mean, there are things that market in time, and there are things, he'd have a high-vis vest on today, right? And he'd have a laptop with a 3D model on the laptop. And so how do we think about the realm of design? I call it a design site versus a construction site. And the design site relies on that digital model, but if you can't build it to the level of accuracy in your Revit model, then what are our assumptions about that space of construction? So those interactions. The other reading of verifying field is, before you act, right? Measure twice, cut once. Before you act, you want to sort of pause and look around and say, what's going on? So verification also means taking stock of the world around us. And I found this image at the beginning of the pandemic, and there's something weird about it, right? These ladies are sitting a little bit too far apart. They want to talk to each other. They're social, but they're not sitting on the same bench, right? Because it's social distancing. This is like an image of the pandemic that we all sort of remember, but there's a kind of awkward spatial cues in this image that I think help us sort of take stock of the moment. At the same time, we think about our interactions with each other, our interactions with the world, and they're always somehow mediated by these devices. And if I have a 14-year-old daughter, their interactions with each other and with their devices are completely different. And so how do we take stock of the present moment? Not just architecturally, culturally, politically. How does technology tie us together? We say we've never been more connected. We've never had as much information. At the same time, we've never been as sort of doubtful of what is truth anymore. You could say we live in the post-truth world, right? There's so much information, but we can't discern what's real and what's not, what's true and what's not true. We've also never been so polarized politically. And so how do we take stock of these conditions as a kind of backdrop of our lives and a backdrop of our practices? How might architecture participate in civic life, in cultural life, in political life, in global affairs? And what are the cues that are giving us information about these conditions? You know, we've seen the news. How does architecture participate in these questions besides, you know, combustion? When we think about our heroes, we're talking about heroes. You know, do we still have heroes? Our heroes, Charles and Ray Eames. You know, when someone asked Charles Eames, you know, what are the limits of design? He said, what are the limits of problems? And so he expanded the realm of design to be almost limitless, basically. Is this mic acting a little weird?
Yeah.
I got another one here.
Okay, that's fine.
I'll try that. Okay, how's that? Is that better? Okay, I'll keep going. So, what are the limits of design? What are the limits of problems? Design is not the same as problem solving, but I like the ambition of this like expanded notion of design. Years ago, we published a book called Expanded Practice. We thought, oh, architecture seems too narrowly defined. We're ambitious, we want to work on landscapes, we want to work on interaction, we want to work on clothing, art, public art, and so this was our first book in 2009. We were doing projects like this. We were building immersive installations. My wife was at MIT. We were working on microcontrollers, light and sound. And so this moment, I said, media is a material for design. Media is material. Think about it like concrete and brick, so media. Recently, we've been working on projects where we're thinking about material, real heavy stuff. And so I said, well, maybe it's about material after media. So we're all working computation, we're working with digital tools. We're still working on stone, but we're not carving it the old-fashioned way, we're carving it with digital fabrication. So material after media. So that was actually the foundation of this book, which was called Verifying Field, which is sort of what I'm going to talk about today. So these interactions between the design space, the design site, and the construction site. I'm going to show a number of projects. I think they illustrate some of these questions. So before the pandemic, we won a competition in China. It was for this park in Shanghai, which was an industrial site, became the expo site in 2010. And they were asking for 2 bridges in this new park. It's meant to be like a central park. And we said, instead of 2 bridges, how about 1 bridge? We could just do 1 bridge with a hole in it. And so rather than 2 discrete bridges, we said 1 big bridge. It's wider than it is long. And so it's not really a kind of structural question. This is our submission, our rendering. And over the pandemic, we sort of interacted with them, and then they built it. And so I sent this photograph to Stephen Hole because he was editing Domus, and he's like, I don't publish renderings. I said, it's not a rendering. It looks an awful lot like one. But you never know. In China, they say in China, anything's possible, but nothing is easy. And we found that to be true. It's not easy to build anything in China, but it's incredible what they want you to build. They're hungry for design. So until we start seeing construction documents in Chinese, we're always skeptical. And then they were sending us photos like this. So there's the bridge, the other half is over there. What we discovered during construction was that they'd actually put a parking garage under the lake. So it's a parking garage with a lake on top, with a bridge on top. Only in China. So we said maybe we could do a toroidal formwork, curved in 2 directions, stainless steel forms. They said fine. So the underside has this beautiful curvature like the hull of a ship. The top side, the granite blocks are the pavers, and then they turn into these blocks. Are very textured. We wanted to see all the blocks. We wanted to see the units. So we see the unit of construction. And whoops, volume. So that's the outcome. There are these sort of jutting out pieces where you could imagine looking out over the landscape. When we did the competition, I was thinking about these Chinese landscape paintings where there's like a solitary scholar, peering out over the Chinese garden, and I thought, we have to have the ability to produce that moment where there's a kind of contemplative moment where a solitary person is looking out over the water, and maybe two people, or a multitude. This is wide enough that you could have a festival here. It's really a plaza built over the water. But remarkable how to propose something in a context so distant, where you're sort of trying to convey an idea. And how do you convey that idea not just to the owner or the city, but also to the builder? And how do you make an idea so legible that it's evident to the people putting it together? We also did this project in Hainan, which is the kind of tropical part of China. We sent the drawings over. We never thought they would build it, because you never know. So this was a kind of landform. It sort of takes the highest point of the site and extends it into this coil. It's meant to sort of look over the landscape. We like to build models like this, form volumetric, and then we try to work out the structure with an engineer. And then we coordinate with the local architects, the local engineers, and sort of going back and forth. We were Zooming before the pandemic, and so much of work in China is done over Zoom, and so we got really good at communicating over Zoom. These are the plans. It's kind of a coil, and there's a kind of viewing gallery that looks out over the landscape. We clad it in, the client wanted to clad it in green, and in Hainan you can actually grow things on buildings. It's lush and tropical, and then we had this sort of weave, this hypar weave of members to give it a kind of almost like a basket-like quality. We coordinate our plans back and forth, and cutting sections, coordinating structures, and then one day you get this in your inbox. You're like, oh my God, they weren't kidding. And it's those lapses of communication where months go by, you don't hear anything, and then they send you this. And so you're like, wow, that looks a lot like the drawings we sent over. Not exactly, but more or less. They say in China it's not less, it's more. It's like more or less. More or less how you drew it. So we were shocked by this view, which is the view out the kind of throat of it. Incredible landscape. And the client kept saying, make the view wider, make it wider. And we're like, no, we want to frame the view. And then you realize why he wants to make it wider, because he's got this incredible landscape in front of him. So this is another one of those construction photos that comes in. Here's the landscape sort of climbing up, and you can climb on the outside, or you can go inside and climb on the inside. We just got these fairly recently, and you see it in the context of this topography, in the context of the foliage. It's kind of astounding what they're asking for. In China, they really want design to do stuff. I feel like sometimes our clients here don't really want design to do much. So the ambition for design is incredibly high in China. Another project in China, same developer, same client. I remember people were very apprehensive, working in China, will you get paid? And at a certain point, you sort of have to just believe. Maybe people get burned, but at a certain point, we just went for it. And after a few good experiences, I feel like we keep having great experiences working with Chinese developers. So this is another project in Chengdu. When we first started working in China, I'd never heard of Chengdu. It's a city of 10 million people. I asked my mom, who's Chinese, I was like, have you heard of Chengdu? She's like, yeah, I was born there. Okay, so it's good to know. Of course, I told my client that, and they're like, well, do you speak Chinese? And then I was like, no, okay, well, then you're not Chinese. But we've been doing a lot of work in Chengdu. And so these are 3 residential towers in Chengdu. You'll get a site plan like this, here are the towers, and this is the context. So it's not really urban, I wouldn't say. I don't think this is urbanism. Is it landscape? Not sure. I think the Chinese are redefining what's a city. They're redefining what's a landscape. In a way, they're redefining what is architecture. We were given these floor plates, and in a way it's better when they do the floor plates because they have the code compliant stairs and elevators and everything. And we thought we would just do the balconies. If we can modify the balcony, the slab edge, that's the project. So in a way we were kind of sculpting, so shaping the 3 towers, and then turning those into floor plates. If you look at Aqua Tower by Studio Gang, it's really a floor plate project, but those floor plates are so thin, right? 6 inches is defining the form. I said, let's give you the whole balcony. I want the whole face of the balcony to define the form. So going from a shape like this to a shape like this, and recognizing that we can sort of create this, and the sculpting of the building is really on this edge of slab. And in a way, we just leave the plans the way they are because we're not going to actually change the units or the marketing or the leasing or whatever. We can actually focus on that squishy zone between the face of glass and the edge of slab. And that became the project. And so all these floor plates from the waist in the middle, which is sort of most constrained there's the constraint to the top, it all changes and the balcony grows, and that's how we get the kind of expression. So here I was looking at Aqua Tower and saying, well, that's not a whole lot of surface area, but if you do this, you can sort of get that full expression of the face of glass to produce this effect. I was also skeptical that they could do curved glass, but they assured me that it was possible. I was ready to kind of facet or lap the glass. But these are the kind of studies we do. This is the kind of trying to define the face and produce that curvature with very, very subtle adjustments in the edge of slab. Right? If you sort of scooch out by 6 inches on every floor, you can produce that sort of bow in elevation, which produces that sort of sculptural quality. So these are the kind of drawings we're doing. We're trying to, in this case, hold this gap and then curve that one just by modifying the edge of slab. And these are kind of the geometry drawings that show all the different circles and all the center points where those slab edges are being derived from. I did visit China right over the summer, and I saw the sales center, which is a kind of full-scale mock-up. So I saw the kind of curved glass there, and got a sense of, what does it feel like to be on a balcony between this rectilinear volume on the left and the kind of curvatures on the right. The glass is going in, but sort of the space between these two curves is sort of the space of that balcony. And that's sort of revealed between the curves, so we're trying to accentuate sort of disengaging those two faces. That's sort of coming together. And so that's the rendering. And then I got this a couple of days ago. When you give a lecture, it's a good excuse to ask your clients for, updates. It's like, what's happening? So yes, it's maybe a third of the way up. And this is, astounding how quickly they're moving on this, because this is, I don't know, this project's maybe 3 or 4 years old. The same client has been doing all these kind of waterways, and so to design a kind of water town, they need lots of pedestrian bridges. And so they asked us if we had any ideas for a bridge. We said, sure. Who's designing that landscape? We don't know yet. I said, well, maybe the bridge will produce the landscape. So the landscape is a byproduct of the bridge. And if you look at these lines, they're kind of like they're spinning a series of lines. The lines are producing retaining walls that are holding back the earth, but then the same line is sort of producing the underbelly of the bridge. So a clever idea. Our client's smart enough to know when he sees a good idea, and so he said, let's do that. And so a concept like this, where you say, well, let's stack this kind of hockey stick, and then we'll spin it out, and it'll produce both the bridge and the landscape. You sort of recognize that as a good idea. So the underbelly of the bridge is actually the sort of terraced inverse of the landscape on the other side. And so it sort of cantilevers. It's not really a cantilever. It sort of gestures as a cantilever in this direction, where we're seeing the sort of terraced underbelly of the bridge here. And that's what it's supposed to look like. So, I mean, I think working in China, we're sort of we're distilling an idea down to something that's easily communicable, right? It's not so willful, it's just kind of like, oh, there's a logic to this. And as long as you sort of follow this logic, then the idea will be legible. Some of the drawings of the stepped cross-section of the bridge. And then communicating not just with the local architect, but also with the builder. And I think that's what we've learned is like, how do you make your drawings like super legible to the people that have to build it? Coming back to the States for a minute, we work in Boston a lot. Our office is over here somewhere. This is Boston Commons, this is the South End, this is the Massachusetts Turnpike. This is a small neighborhood called Bay Village. It's a beautiful little historic neighborhood of 2-story buildings. We were asked to look at a 20-story residential building in a historic landmark neighborhood. And so our client came to us and said, well, can you design a building that belongs in Boston? And I said, sure. And then they said, what does that mean? I have no idea, but we'll figure it out. So we tried lots of things. Turns out, this historic landmark neighborhood, our building is like just on the edge of it, but there's also a number of rather tall buildings along here. And so it's sort of straddling between the high spine, which is this, Kevin Lynch called the high spine, and then this sort of historic neighborhood here. We took stock of what was around us, beautiful, 1- and 2-story brick buildings, and then there are some kind of brutalist towers nearby, a whole range of materials and a range of different architectural styles. We sort of cataloged everything in the neighborhood, and then we went to community meetings for about 2.5 years. But this was what was existing, a kind of a disamenity, really, a parking lot in the middle of the city. The only reason no one developed this site was because it was too small to park, right? You can't really park it efficiently. And so our clients, who were very smart, they rented a bunch of parking spaces from this hotel next door. And so development needs to be super creative to produce creative architecture, right? You can't do creative architecture without a creative client. So our clients are creative. We got 7 units per floor, jammed tight in there. If you've done multifamily, you'll see how tight that is. This is a site boundary, basically. And then we started playing with plaster. We were making these plaster casts. We thought maybe these could be cladding material, like these kind of flutes, to be a little bit sort of classical. And then we sort of carved them out of limestone with some robots. And then we carved it out of EPS foam in our shop. And then we proposed it to be precast. So we sort of studied precast. And I had a hunch that a really long piece of precast we can get on a truck and drive it into the city, because really the limits to modules are the DOT standards, right? The 13 foot to the underside of that bridge, like that little yellow sign that's on all those bridges, like that's an architectural constraint, right? I believe in architectural constraints. Constraints make our architecture better because we have to follow those constraints. So, the DOT doesn't say anything about length. Right? We could be 30 feet long, 40 feet long. But we had these profiles. We thought it would be kind of beautiful to get these shapes optimized for, initially we optimized it for the mold, thinking we can do a couple of molds and get all kinds of variation or repetition. Turns out they needed to be optimized for the crane. Right? Crane time is the expensive time. And so rather than have a bunch of little pieces, we sort of had these bigger pieces that were really efficient to pick and to place. So these beautiful panels, 6 feet wide, with these curves, really, I could just look at those curves. They're so beautiful. But these are the building units, and when they go on the building, they go up 30 feet at a time. So large panels, large. In this case, this is a party wall, so opaque surfaces with all this undulation. And what I realized is that so much contemporary architecture is flat and taut, and historic architecture, regardless of style, is rich and deep and thick, casts shadows, takes your eye around it. And so we got approved in this historic neighborhood, not because we followed this style or that style, but because we convinced them that we were really interested in something of really high quality. And quality had to do with something that looked durable, that sort of encouraged your eye to move around it. And so these are the piers. The glazing is really just the gap between the verticals. This is under construction, which is when buildings really look the most beautiful. This is a detail with this window wall that sort of spans in between, the joints between the panels. I was telling Brad last night, we learned a lot doing this. It turns out a 30-foot panel gravity loads on one slab only, and so that one slab is deflecting a lot. And the other slabs, which are carrying the window wall, are not deflecting. And so the window wall is not moving, but the whole pier is moving, right? So a lot of differential deflection that's taken up in the joint sizes, Students ask, so how wide is my joint? It's like, well, how much differential deflection are you getting? So if you want tight joints, don't do this. But it does look good. This looks like a rendering again. It's a photo. This is our east facade, which is actually a party wall. So the glass is a window wall that's just filling the gap. We really wanted to diminish the presence of the spandrels, try to get that as recessive as possible, giving all the depth and the kind of shadows cast along these sort of coursing lines to really articulate the height of the tower. The other big lesson I learned here was that these neighbors here, these are the ones that are coming to our community meetings, right? And these neighbors live in 2-story brownstones, and they have a little stoop, and they have a little flower box, and they've got all this decorative ironwork and beautiful shutters. And they come to the meeting, and they say, I don't want to look at your loading dock. I don't want to look at your louvers. And so we put the loading dock on the other side. We put 2 townhouse units facing the other townhouse units. And I said, you're not looking at the loading, you're looking at your neighbors. They're neighbors across the street. There used to be a parking lot, now they're neighbors. And so that sort of tripped a switch, and I felt like everyone on this side of the street started to support our project and come to meetings. And so I said, the street, Shawmut Street, it's a very short street, it has 2 sides, and we need neighbors on both sides, right? A good street is not just one-sided. It can't be. And so in a way, urbanism is what sort of tripped the switch that allowed this piece of architecture to move forward. I say they're architectural ideas, but there's also some sort of alchemy which is called urbanism. And when you have neighbors across the street, when you have little stoops and ironwork and planter boxes and front doors and doorbells and people coming and going, that's when architecture starts to produce that sort of magic which becomes kind of urbanism. So that's what it looks like. It's 20 stories. When we got approved at Landmarks, our client looked at us and like, oh, we didn't think you would succeed. What do you mean? You didn't have faith that we were going to get approved? They said no. So we surprised them. We surprised ourselves to persuade people that this is a good thing, that this piece of architecture will make the city better, that it will hold up in the context of all these beautiful historic buildings. So we're learning to build a little bit in the historic city. I threw this slide in here because I teach construction at the GSD, and so you guys recognize this image on the right? Seagram building, right? Our students are like, why are we learning about Mies? Why do we need to learn about the Seagram building? Because Mies is so deliberate, right? Mies is so rigorous. The mullion is on the column line. And then the spacing of the mullions, it's subdividing that structural bay, right? And if you put the mullion on the column line, then you're always going to have a leftover, right? And what's in that leftover, we don't know. The column size could grow or shrink, but that leftover is what produces the Miesian corner. Harry Cobb used to say there's 2 kinds of architects in the world. They're the architects that dimension to the center line, and the architects that dimension to the face, right? Think about that. Are you a centerline architect? Are you a face architect? I spent years worrying that I was like the wrong kind of architect. I was like, I really want to go to the center line. If you go to the center line, the module can change, the beam, the column can change, the mullion can change, everything can change, but you still got the center line locked in. But you sort of need to dimension to the face when you're doing this, right? You need to know where that face is. It's a trick question. You're both center line and face. And then in terms of Mies, I like to sort of flip this back and forth because our precast concrete piers are kind of flying by, and then there's always a piece of glass there that allows that precast panel to sort of jut out and show you its thickness, right? You see how thick that panel is because it's slipping by. I like turning corners because you see what it's made of, you see how thick it is, what its dimensions are. And in a way, Mies is showing us how thick that column is. He's showing us how thin the curtain wall is, right? You see the thickness of the system. Architecture has depth, it has thickness. It's not just a line, it's not just a NURB, it's not just a rhino surface. Anyways, here's my polemical image, Mies and Stewart Street. Mies is a center line guy, by the way. We think we're both. And so here I am standing at the base of one of these flutes, and in a way it's sort of scaled to the body, right? You can almost stand in there. It's like shaped by the body. It's spatial. It's a kind of gesture. It's a kind of embrace. I was just in Indiana last week. We built this house in Indianapolis for a couple that saw one of our projects and said, we'd like you to design our house. We designed a house, we call it the Plus House. They saw a project in Dwell, we said, we'd like one like that. I said, no, we're going to design a new house for you. And looking at the site, there's a kind of artificial pond, there's some mature trees. We thought maybe a quadrant house will have an orchard on one side, a pond on the other, and a pool on the other, and the house will sort of subdivide the site, and it'll frame views, from its ends. So that's the Plus House. This is our concept model, where the garage, and we thought an amphitheater here looking out at the pond, and the slides in and becomes a stair on the inside, but these big viewing portals are sort of looking back at the landscape. So we got the main portal here, and you'll notice that the thickness of this frame, how does this turn the corner? It turns the corner on a knife edge, so it really obscures the thickness of the wall, it obscures the thickness of the floor package. So you see that knife edge all the way around. I tell my students, you really need to think about, what is the depth of that floor package? Is it like structure that's coming at you? And what's the depth of that wall? And how do you size those differently? We had done a project with some knife edges before, and I think they're really beautiful because it really masks the thickness of architecture, but it tends to be a kind of articulation of the corner. And in this case, we thought we'd just follow that in and start to create a poché zone in the house and a kind of poché zone. And so these thicknesses sort of travel through the house, and they try to build an architecture of kind of thickness, even though it's also made of drywall and furring and cladding. But in section 2, that line comes down. It's not just a profile on the outside. It actually starts to create a kind of spatial condition on the inside. I say this is an upside down attic space because it has a slope on the floor. The master bedroom and some of the kids' bedrooms upstairs. So it's sort of an evolution of a series of ideas that we've been exploring, like how do you turn a corner, how do you sort of think about thickness, and how do you mask thickness. I like to say that this knife edge, it conceals in a way the material because you never see how thick the cladding is, and it produces that sort of illusion of maybe it's kind of infinitely thin, right? If you line up your eye with that, you sort of get a moment where you're not sure what you're looking at. And sometimes when you look at a view of the house and it's sort of lined up like this, it sort of dissolves the thickness of it, and it looks kind of like a rendering, right? It's like the material is really just almost like a texture map with no thickness. And I think that's interesting when architecture starts to look like a rendering, and it starts to make you question, it's really material, it's in the world, but it's actually impossibly thin, or it produces the illusion of thinness. So I like looking at this house and seeing, those chamfers that are sort of masking, in a way, the thickness of the whole second floor, and these sort of chamfers on the bedrooms that are sort of folding in, but always the knife edge detail is sort of obscuring what it's really made of and making you look again. In a way, verification is also a kind of double take. It's like when you look one time and you see something, and you look again and you see something different, and you're like, oh, I saw something new, I discovered something. I think the best architecture makes you look again. It slows you down. And sometimes you see it every day, but then you see something new. And I think that's really beautiful when architecture can reveal something that you didn't notice before. This is the master bathroom. It looks like solid stone. This is a shower. It has a skylight above it, and that skylight goes up two floors. And then this sort of big window looking out over the landscape. So they're really beautiful moments. There's the shower enclosure with the skylight above and the master bedroom. They're beautiful moments. How do you clad a building like this? We propose to clad it out of charred wood. It's something that is a traditional Japanese technique of protecting the wood from termites and rot. Because it's charred, it produces a kind of protective layer. But at a distance, it looks like paint. When you get closer, and you discover this incredible texture of the kind of charring process. It also has a sheen to it, so in certain light, it sort of sparkles. It's kind of incredibly beautiful. Our clients were adventurous. They didn't mind their house looking like a ruin, and they were willing to do it. So there's the house. The last detail, these windows. I think the hardest thing to do in architecture is a window, actually. It's hard to do a window, a good window. When I was a student, my professor said, it's not a window, it's an aperture. And I was like, oh boy. But then I find myself saying the same thing to my students. I'm like, it's not a window, it's an aperture. So what is a window? It's something to bring in light, it's something to let views out, it's something to create ventilation. It's it's not just a window. A window is a product, and in a way, apertures do different things. So this aperture, it's a narrow proportion. We wanted it to wrap over, right, to sort of slip over the top. And how do you do that without a skylight? So it's actually just a normal window, but there's a gap. But look at what it does in the hallway. The light coming in sort of wraps over, and it's not a kind of, I say a window is an exception to a wall. It's like a punch. And it always comes with a lintel, right? And so this particular window has this notch, which makes a light sort of fold over, and sort of it becomes kind of spatial, sort of space defining. So there's beautiful little detail moments in a residential project. My wife likes to do residential. I find it very difficult, actually, because you have to deal with clients and and their toothbrushes and their laundry room and their vacuum cleaner and their and so. But I do appreciate that a client that has particular needs and is willing to accept exceptional conditions and appreciates design can really realize something quite special. Shifting gears, years ago. We sat down and I said, what kind of work do we want to do in 5 years? And we said, we'd like to do cultural projects, we'd like to do institutions, we'd like to do higher ed. And we're like, how do we do that? How do we get there? Someone said, Tadao Ando said, if you're designing houses but want to do museums, design your houses to look like museums, and then that's where you'll go, right? Someone will ask you to design a museum because you design a house that look like a museum. So we didn't do that, but we did say we'd like to do cultural projects. How do we do that? We'd like to work for higher ed, for institutions. We did design, in addition to this movie theater in Boston. I love the Angelica, by the way. In New York, I used to go to the Angelica all the time. So I love alternative film. I love communities for film, and this is in Boston. This is our neighborhood theater, the Coolidge. At the interview, I said, it is a community of film lovers, right? This is where film lovers go to watch movies and to hang around and talk about them afterwards, right? That afterwards, that before, is what these places are about. So it's Art Deco. You'll notice the kind of brickwork here, the kind of herringbone brick there. I said Art Deco is not a style. It's an attitude about technology. It's an attitude about progress. Think about radio, electricity, film. Like that's what was driving Art Deco in the 1920s. Fast forward 100 years, right? We're still, at the cusp of a technological revolution. Talk about digital, talk about AI. Like, there's a kind of enthusiasm for articulation, intricacy. It's like an echo of Art Deco today. Like, and our client asked us, like, how do you think about computation and Art Deco today? And I was like, actually, they're perfect. They're perfectly aligned in terms of attitudes about progress and technology. So that was nice to have a client that sort of started the conversation with a really provocative question like that. This is the backside, and this is where our audition went. So they said, can you do something with this parking lot? And we said, yeah, we can put 2 movie houses here. You see the marquees over there. So the marquees on Harvard Street, this is the back lot. And we said we're going to turn them back into a new front. And so we proposed this, 2 new movie houses, this glass lobby. There's a community center on the roof and another theater up there. And then, the brick on the front is this sort of sand-colored brick. And we're in Boston, and we said, what can we do with brick that's a little different? Maybe the brick it's animated somehow. It feels like it's undulating, it's rippling. This is the south face. It's getting all this bright sunlight all the time. And so we proposed a kind of concavity that was articulated with every brick module. So it's not a smooth curvature. It's a kind of deliberately staggered one. And here's the kind of primary movie house. This is where I watched The Brutalist last week on 70 millimeter. This is movie house 5, and this is movie house 6. And there's our lobby. So we're adjacent to all this incredible articulation. And we're not going to reproduce that in the new, but how do we develop an attitude about old and new that allows you to step from one world into the other? I think about Dorothy, right? Stepping from the black and white world into, like, I forget what that was called, chroma-color or some color. She stepped into a world of color. So we said maybe when you step across the line, you're really stepping from one world into the other. Maybe these theaters are color-coded. Here's the brick study. We thought maybe the tiebacks could just get a little longer to allow us to do that curvature. At the very last minute, the contractor's like, hey, wouldn't you rather just align them like on a curve like this? And I was like, no. I like the stepping, I like the texture. And he's like, what about icicles? I said, oh. I hired an icicle consultant to figure out like how deep those little ledges could be so we wouldn't have icicles. But look at that, how beautiful. Every brick is set by hand, right? No robots yet. But it produces the curvature, but it articulates the parts, right? It articulates the part-to-whole relationships between the brick, which is scaled to the hand of the mason, right? The mason has to hold it in one hand with the trowel in the other hand. So the body of the mason is inscribed in a brick wall, like how beautiful. So this is a construction shot, but you see that sunlight hitting the facade and really animating it, right? It's like alive, it's like dazzling. This is another construction photo. When we were talking with the owner, they were like, well, what can you do with color, right? Color was something you can't VE color, right? So we're like, well, maybe this is a kind of gold bar, it's like gold leaf, and maybe it's got some sort of sculptural parts that are shaped, giving these little convexities, concavities, and we thought, maybe this just evokes something. It evokes something familiar that's almost subliminal. So maybe the architecture, we all have this shared repository of images, like this like blue room with this sort of red room beyond from 2001. So when you're talking to like film people, you sort of have to bring your kind of references. Even if they're subliminal, you don't even have to talk about them, but you say, we want a red room, and we want a gold room. But this just opened, and for us, it's also important to not just do new buildings, but also to work on old buildings, to find value in those old buildings. And in a way, an institution like the Coolidge is always a little bit precarious. People said, are we still going to be watching movies after the pandemic? In fact, we are. We desperately want to be together in a dark room, looking at images, flickering on a screen. Like, that's a collective experience. We don't want to lose that. And so We won a historic preservation award for this project, even though we didn't actually touch the old building. We actually added to it. But in a way, the addition of these new houses and the old houses together, it helps to preserve this institution, making it economically viable. So the economic viability is being preserved through an architectural project that's sort of extending the life of it and bringing different audiences to it. So that was kind of a lesson learned. A few years ago, and I think Mijin might have shown this when she was here a few years ago, so forgive me if I tell you something you've already heard, but she tells the story completely different than I do. So MIT, Boston Marathon, 2013. In the aftermath of the marathon bombings, the two Tsarnaev brothers were on MIT's campus, where Mijin was a faculty member, and they killed an MIT police officer to get his gun. So Sean Collier was killed on MIT's campus. And that was obviously traumatic. Everyone said, how could this happen? Domestic terrorism. They asked Mijin to design a memorial for Sean Collier, and we said, what is that? What is a memorial today? What is the status of memory when we have a kind of attention deficit, right? We have all this technology, we can't sort of focus, we can't think. And so there was a campaign, I don't know if you remember, Boston Strong, MIT Strong, Collier Strong. And so Mens et Manus is MIT's slogan, like, hand in mind, fortis, strength. And we were like, what is strength? You know, for an engineer, strength is something very specific. For a community, what is strength? Is it resiliency? Is it a sense of belonging? Is it about difference? And so this is the site. This is the Frank Gehry building, the status center. I said, how can you be contemplative here? Very difficult with this thing here, right? I wanted to create a sense of enclosure, a sense of screening, an interiority, right? But you can't create interiority in the public realm because it doesn't feel safe. So, and someone said, well, he's a police officer, maybe an American flag, you know, maybe some stars and stripes, you know. And they said he loved nature, maybe a boulder. And then someone said, what about some trees and a pool of water? Like, everyone has ideas of what they want out of a memorial, what's appropriate. We said, well, we don't want to do stars and we don't want to do stripes, but maybe there's something that's ambiguous like this star shape. Maybe it's a hand shape, maybe it's hand in mind, right? Mens et manus. And maybe that has a boulder that was intersecting with it, and so we take the boulder out of it. And we produce what we call a conspicuous absence. Like, you go there, you're like, oh, there was something here. There was a boulder that was just here, and now it's gone. So you feel the presence of that absence, you feel the kind of, the trace of its subtraction. And so here is the plan. His police car was right here. And so it was, you know, when you stand in the middle, you sort of get a frame view of his police car. There's a video here. You can't play. Okay, never mind. Mijin wanted it to be solid. And so she told the contractor, I want it to be solid. And the contractor said, how about a veneer? And she said, I don't know what that means. So it's solid stone blocks. The contractor wanted to post-tension it and skin it with stone, and actually that's a bad idea. Like, imagine all the work to carve the stone front and back, and it'd be a pain. In a way, stone blocks make a lot of sense because it's an arch. Arches are solid. The keystone wants to fall. It can't fall because there's a stone next to it, and it sort of transfers loads to the adjacent stones. And so there it is. It's a five-sided, irregular stone vault. And we worked with our structural engineer, John Oxendorf, who's a professor at MIT. Hauke Jungjohann is a structural engineer out of Stuttgart. Actually, he was working in New York. And Sam Morelli was project manager at Suffolk. And so here we are, trying to figure out how to build an arch, a contemporary arch, right? Nobody had any arch building on their resume, right? Hadn't built an arch in a long time. Turns out this arch is different. It's incredibly horizontal. It's a very low thrust. And so these calculations that show the force vectors in a way staying within the shape, within the form, but grounding all this force in the buttress walls. The length of the wall is a function of its resistance to the thrust line. And it's an irregular shape, this sort of five-sided figure, but the thrust lines are always perpendicular to that last joint. And so we figured out how to do an arch today. We have 33 unique parts. They're all made of solid stone. And in a way, we had to make it extremely precisely, right? Because stone's a natural material, and so there's no real redundancy in it, right? There's no post-tensioning in there. It's all compression. We don't need tension, just all compression. So also we had to procure the stone. Turns out most stone is quarried for countertops, and so it's like optimized for certain sizes. And if you want to build a keystone in a five-sided irregular stone arch, you have to go to the quarry to find the right stone. So we procured the blocks. We sort of learned about digital fabrication, not even digital, this is like analog fabrication. And we produced all the documents. We stamped the drawings. We handed our files over, right? And so even though there's this incredible legal tension, right? You're not meant to do means and methods. You're not meant to take on that risk. You need shop drawings and you need all these controls, all these QA/QC mechanisms to separate the designer from the builder. But your files are going back and forth, right? So the fluidity of file transfer versus the kind of reality of risk mitigation, that's one of the fundamental tensions in contemporary practice. So we produced the drawings, we sent over our files. I was talking to the fabricator, and he's like, well, how do you know where the edge of the saw is, really? And I said, well, you have a certain saw diameter, it's got like diamond tips, and it's cutting the stone. And he's like, well, but you think the diameter of the saw is constant? I said, well, I don't know, it's cutting the stone, right? And he's like, yeah, but the stone is cutting the saw. So every time you cut, the saw blade is getting smaller. I thought, oh my God, I have to worry about the saw getting smaller and the calibration of the saw. So Brad and I were talking about precision, right? In contemporary design, digital tools, we think about precision of the digital. When it translates into material, it often cannot maintain that level of precision. And so we're often disappointed when something material comes back and it's not as precise as our digital model, right? So how do we maintain precision in the materialization of architecture that's been conceptualized digitally? So this story about the saw diameter really sort of blew my mind as I was thinking like that translation of our digital model into this massive stone block. And then we had to sort of redevelop sort of QA/QC processes to verify that this stone was in fact the same size as our digital model. In fact, if we had time, we would have scanned it and compared the scan to the cut file, the toolpath. Turns out we didn't have time, and these things had to ship, and they had to get on site. And so here's one of the first blocks showing up. It's Virginia mist. It has a beautiful feathery vein in it, and it wraps around, and so you see it as a volumetric thing. If this was just an absolute black, you would never really know. But if it's got a vein in it, it sort of shows you the kind of three-dimensionality of the stone. It's so beautiful. So here's the keystone that went in first. Remember learning about Roman arches, the keystone goes in last, right? You talk to the contractor, like, shouldn't it go last? Turns out they wanted it to go first. Why? Because it's five-sided. Every side has a step, so it's 15-sided. And they said, if we put that keystone in last, we've got 15 faces that need to be perfect. 15 faces. 30 faces. 30 faces that have to be perfect. Not very likely. If we put the keystone in first, and then we bring the adjacent stones to it, we can take the tolerance and shed it to the perimeter, right? And if we need to modify the fabrication of those pieces, that's better. So listen to your fabricator when they say, let's do it backwards. Ask them why, and then figure out together what's the best way to do this. So we built it up in the air. This is floating in the air. You see the scaffolds holding it up. Keystone goes in first. Amazing. John Oxendorf had his graduate students build these massive scales, and so they weighed all the stone, and they were monitoring it in real time. As they were lowering the scaffold, they were trying to measure the weight of the stone on the scales in the middle should go down. Right? If you lower the scaffold, they're not seeing any load. The weight on the other stones should go up, right? And it took them 8 hours to do this. But they were monitoring in real time. There's a couple of MIT dissertations based on this project. They wanted to know if they can calculate it accurately so that when they build it, would the built thing match their calculations, right? What does it mean to engineer something? What does it mean to design something, right? To design something is to anticipate a future performance of a material. To engineer something, you have to imagine how that steel is going to perform before you build it and then after you build it, right? If you can confirm and verify that, in fact, it deflected a 1/16 of an inch after we remove the scaffold, then you've got something. Then you can engineer it. If you can't predict its behavior, you can't design it, you can't engineer it. Interesting. So after 8 hours, they hollowed out the conspicuous absence. They witnessed this figure for the first time because it was full of scaffolding. This is Rob. He was Sean Collier's half-brother. He was the foreman on the job. So incredibly emotional moment for him, right? He's building this thing day after day, and he sees the void for the first time. Really powerful. If you visit MIT today, this is on the corner of Main Street and Vassar. There's an MIT sign over there, Status Center's over here. But it produces a 5-sided figure. It's like 5 rooms joined by 1 room, right? There's 1 room that ties them all together. And that's one way to think about it. I say it's also a gateway. I say it's something that you walk through every day. Maybe you don't think about it. But sometimes you look and you see that hollow and you think, wow, there's something missing here. And this stone has been flamed, so it's rough, and this stone has been honed. And so there's a very different sheen on the inside. And this is concave, and so when you walk in there, there's a different acoustic quality. If you didn't have vision, you could walk through there and you could hear when you were inside of it. You could hear the absence of this figure that's missing. I don't have a picture of it here, but there are also lights in the ground that are sort of, we laid out the lights in the ground on the constellation of stars that was in the sky the night that Sean Collier was killed. And so some people look at the lights and they're like, they look like lights, and some people will say like, oh, what are these 3 lights in a row? And I'm like, well, that's Orion's belt, right? Those 3 stars in a row is Orion's belt. And then you're like, oh my God, this is a constellation. And then they look at it, and then they think about it. I do think the best architecture makes you think about it. It makes you see things differently every time you visit, right? You should see something new. So more and more we're kind of interested in this kind of stuff, this material. Like it's not media as material, but it's material after media, after we've modeled it and fabricated it and erected it and surveyed it and occupied it, photographed it, Instagrammed it, shared it, commented, liked it, forwarded it. It's really material in the world that's gone through this process. So this was the next book, and we talked about Collier, we talked about Stewart Street. This is the UVA memorial here. So nobody wants to do memorials. 5 minutes? Okay. One last project. So this is the serpentine wall at UVA. Right? This is the kind of undulating wall. Maybe you know about it. Maybe you studied it in history class. I teach it in my class. I teach that Thomas Jefferson, this is his handwriting, his notes, he was trying to build a wall. And he said, if I build a straight wall with these vertical piers to stabilize it, I'm going to have so many bricks. Right? If I build an undulating wall, I don't need these piers. And here he is calculating the number of bricks that it takes to do a serpentine wall versus a straight wall with intermittent piers. And he determines that the undulating wall is actually more efficient, less bricks. So at UVA, you see all these garden walls are serpentine. They're undulating to stabilize them because they used to be 8 feet tall. So I thought Jefferson, the author of the Declaration of Independence, the statesman, the architect, genius. He designed this very clever structural solution. And And that's how I used to teach it. I used to teach Jefferson's serpentine walls. And if you go to UVA, you can observe them. They're quite beautiful, and if you think about it, they're very clever. They spread the base of the wall is spread out, right? The convexity produces stability. It's really, really smart. And so I've been teaching, and I've been thinking about how do we translate an idea into a building. And so, as Brad said, I just sent this book to the publisher. It's Routledge, Design for Construction, Tectonic Imagination. And to be able to imagine architecture, not just the form or the material, but also the labor and the sequence and the tolerance, all those things, I think that's kind of a tectonic imagination. It's not a kind of fantastical imagination. It's something that's sort of anticipating constraints. Maybe it's looped in with information from the builder. Maybe it's that love letter. But I proposed this book to a publisher. I said, this book doesn't exist, and therefore I need to write it. So I proposed 10 chapters. They said, okay, write it. So they sent me a contract, and I signed it. And so I've been working very hard to finish this book. And it starts with the Sydney Opera House and the kind of incredible process from Utzon's sort of early concept to the actual built form. Fascinating story, right? Utzon was fired, he walked away, Australian architects finished it, Australian contractors figured out how to build it. Fascinating story. And I sort of tell a lot of stories in the book about how ideas become architecture. They become material. They become the kind of alchemy of urbanism. Last story is about UVA. And we know UVA because Thomas Jefferson designed it. It's an ideal, he called it an academical village. It's a utopia. It's where students go and learn from professors. The professors live in the 10 pavilions. The students live in these quarters in between. They interact around this open space that has a terminus of a rotunda, which is the library, which is modeled on the Pantheon. You know, here's Jefferson, the architect, the surveyor. He's got a plan. He's looking into the future. What nobody talked about was that Jefferson actually was all those things, but he was also a slave owner. Right? And so he enslaved 600 people over his lifetime. And so that story was never told. We didn't learn that in architectural history class. We didn't learn that about the academical village, right? This sort of Palladian utopia. Nobody said that when I was a student. But look over here. What's happening here? You know, so the truth is hidden in plain sight, that this academical village, this utopia, was predicated on the forced and enslaved labor of African Americans, right? This enslaved woman is taking care of this child, right? So it's hidden in plain sight. UVA was built by enslaved peoples, and these beautiful pleasure gardens that we visit today weren't pleasure gardens at all. They were labor yards, right? These were the places where the enslaved chopped firewood, grew crops, butchered animals, prepared food, did laundry. They did all the things that essentially the university required. And so that's inscribed in the architecture of UVA. This is a section we drew. This is a pavilion. Looks like a two-story building on the lawn side, but it's built on a crest of a hill, and the landscape slopes away, and there's a walkout basement. And in the basement, that's where the enslaved lived, and the yard is where the enslaved labored. Right? So maybe we need to sort of rethink how we think about this academical village. We put together a team to do this with Mabel Wilson, who's a historian, and Frank Dukes and Greg Bleem and Eto Otutigbe to design the UVA Memorial to Enslaved Laborers. This was our project from a few years ago. But we didn't know what a memorial to enslaved laborers was, and so we went through a 6-month process with the community, with the descendants, with the university, with staff and students and historians and scholars and archaeologists. And before we drew anything, we spent 6 months listening and trying to figure out what might it be. And what we heard is that we heard a lot of conflicting things. Some people said, it cannot be whitewashed, it cannot be varnished, we have to tell the truth, the hard truth, the kind of brutal, violent truth about this place. We proposed a ring, an empty ring, not an object monument, but a kind of hollow memorial. And this learned a little bit from the Collier Memorial, right? It's not about a an object, it's about a space, it's about a void. It's also about screening off the context, right? How can you be contemplative in public when everything is happening? It's so busy and so distracting. So it's a landform. It sort of starts low and rises high and comes back down. The inside has a surface for names. The outside has a kind of surface to inscribe. There's a water feature. There's a kind of grassy space in the middle. It sits within a stone throw of the rotunda, which is a perfect sphere. Right? It's based on the Pantheon. This is a cone with an 80-foot diameter. This is an 80-foot diameter. And so where one is a kind of dome, the other is a kind of bowl. One is inscribed in the landscape. But it's somehow in dialogue. And when we designed the profile, I said, if you stand at the base of the memorial with your toes at the wall and you reach out your arm and you connect the line, that's sort of the slope of the wall. It sort of leans away from you. And from the outside, we didn't want you to look in. From the inside, we wanted to sort of screen out the context. So that's the profile of this sort of sloped, conical. There's a conical profile on the inside, there's a conical profile on the outside. And this is our mock-up. And at the base of it all, there's this idea that a memorial is really a community that can gather in a circle, right? A community that can see itself as a community, that it can convene, that it can bring people together. And we translated that circle of people into a piece of architecture that translated all these individual pieces of stone into a single horizon line, right? Horizon is a bounding circle, and when you walk in, it starts off at your ankles, and then it's at your hip, and then it's at your eye level, and then it's over your head, and all of a sudden, the world drops away, and all of a sudden, you're just looking inside. So you see here, it's easy to stand with the wall here, but pretty quick, it's over your head, and when you get to here, it's 8 feet high, because the path is sloping down and the wall is rising up. It's kind of shockingly effective. Eto, who was the artist, found this portrait of Isabella Gibbons, and the community really wanted a representation of an enslaved person. And we said, who should it be? We were kind of resisting, because we didn't know how to do it. We didn't know how to integrate an image. We wanted it to be abstract, but they really wanted this image. And so Eto said, well, let's get Isabella Gibbons. She was an enslaved woman. She was owned by a professor at UVA. And she learned to read and write, and she wrote about her experience. And there's a photograph of her. So Eto took this photograph. He also found this tombstone in a local cemetery, and he said the roughness of this and the photographic image. Eto produces works like this. This is a self-portrait which he inscribed in a material. So he carved the stone to translate a kind of raster image into a series of tool paths that produced the image of his self-portrait. So he took Isabella Gibbons' eyes, and I don't know if this one will play. No. Okay, never mind. There's a little video clip. Okay, but the grooves cut in the stone reproduced the kind of image, and so here's the kind of cleft face and the kind of drill marks and all those things. But there's also an image of an eye here. So this is Isabella Gibbons' eye. It's kind of a colossal eye. So from a raster to a vector to a tool path, that produces this condition where you see the eyes here, one eye, two eyes. And sometimes you walk around it, you don't see anything, and sometimes you're driving down the street and you see the eyes looking back at you. So it's kind of startling. The architecture critic for the Wall Street Journal visited, and he's like, what eyes? I'm like, oh, you have to go back. You have to go back and see it another day when the light is a little different. But I think that's beautiful, that it's almost subliminal. It's like 50% of the time you don't even see it. And then one day you see it and you're like, wow. So a couple other things about this. We wanted to recognize the enslaved, but the enslaved were sort of regarded as property. And so the records really are fragmented. They're extra hands. There's like a brick maker. There's a nanny. There's a family. And so we don't know, they think there were about 4,000 enslaved, but we only have, 577 names. And so how do you acknowledge 4,000 when you don't know their names? So we came up with this idea that we would create a a genealogical cloud, and we carve names when we knew them and blanks when we didn't. Right? So there's an underscore, and here there was a record about a farmer, and there was a Henry and there was an Isaiah, but we don't know this person, we don't know this person, we don't know this person. So there's more unknowns than there are knowns, and in a way that's powerful in and of itself. And this is a placeholder because maybe we'll discover a new name and then we can carve it in there. And so it's inevitably unfinished, it's inevitably incomplete. I was there in the summer and it rained, and then the rainwater got in the grooves and it started to spill out, and I thought, oh my God, it's crying, right? It's bleeding. And I said to Mijin, I'm like, oh my God, look at this. Did you know this was going to happen? And she said, oh yeah, I knew it was going to happen. And I said, how could you know that? You can't anticipate this. She's like, of course it's going to happen like this. Of course it's going to drip out like that. I thought this was an incredible surprise. The interaction of material, of weather, of heat, evaporation, produces an image so powerful that you swear that this is a cut, right? That this is bleeding. It's like those churches in Rome where there's a miraculous statue of the Virgin that's crying or something. This memorial cries, and all these names, the pianist, the mother, the bricklayer, they're so powerful when you see it interacting with its environment. So this is the memorial. It's rough on the outside, it's smooth on the inside. There's a pool of water in the middle. There's inscriptions in the water. This was completed just as COVID hit. So everyone at UVA was sent home, and it was completed just after George Floyd was murdered. Right? So it was a kind of, remember, there was a kind of perfect storm of like pandemic, uncertainty, violence, protest, and people were looking for a place where they could come and be thoughtful, and they started to come to the memorial. They started to come to the memorial and take a knee and reflect, and they came on their own. They came as individuals, then they came as small groups, and then the memorial fulfilled a need, which was a need to be together, a need to be affirming of this idea of a community with values. And so these are the UVA medical students and faculty that basically took a knee at the memorial, and they promised to treat each other and their patients with respect and humanity and dignity. And so this memorial was designed to address a kind of historical wrong, to try to repair and to build a better future. But history sort of came right up into the present, and it started to do work in the present by bringing people together in ways that no scholarship would have done, no academic conference would have done. And I realized that architecture has the power to convene and bring people together and produce a sense of community that all these other good things do, but don't do the same way. So I realized here that the power of architecture to bring people together is really why we do architecture. The coda to this project is that, in fact, these empty spaces they're still discovering names of the enslaved. And so there's new names that are vetted and added to the memorial over time. And in a way, that's a kind of glimmer of hope, right? It's necessarily unfinished, but the kind of genealogical work of finding descendants and inscribing their names is ongoing. And so a couple years ago, they inscribed 5 new names. And in a way, that's like a very small gesture, but they have a ceremony where they inscribe a new name, right? And so it's unfinished, but in a way, it's kind of hopeful that new knowledge will sort of start to fill in the blanks that were sort of necessarily left sort of empty by this kind of historical institution. So when people ask me, like, what's the definition of design, I refer to Herbert Simon, who says, science is the study of the world as it is, and design is the study of the world as it ought to be. And I think that's such a powerful way to think about design. It's the world as it ought to be, and that's why we do what we do. So, thank you.